welcome to video on feedback amplifier. So here in the previous video, we were discussing about a practical case of series and feedback amplifiers. So we considered a voltage source having a source resistance RS, and we considered a load of RL, and of course we considered a feedback network consisting of R1, R2. So that's how we proceeded, and then we could actually able to bring it to this particular form. So this is the actual circuit that we have considered. So this has been brought to this particular form, so that now what all non-idealities we added for the source, load, and the feedback network has been moved to this amplifier. Now we can see we have an ideal source, ideal load, and an ideal feedback network. So since they have been moved on to the amplifier, that is H11 RS, and this RL and H22 have been moved to this, we have to actually find out what is the new gain of this amplifier. Okay, before that, let us try to take some typical values of this amplifier for understanding its effect. So let us assume that A naught of this particular amplifier, that is the open loop gain of this, let it be 10 power 4 volt per volt, and let us assume that the input impedance is around 100 kilo ohm, that is this RID, and let us assume that the output resistance is 1 kilo ohm, and let us assume the feedback resistance R1. So actually this R1, whatever we are considering here, so this is how the feedback network looks like. So this is connected to the output, and this is how the feedback network, this is going to the input, and this is coming from, this is sampled value. So R1 is assumed to be 1 kilo ohm, and R2 happens to be 1000 kilo ohm, which corresponds to 1 mega ohm. And then we have the source resistance, let it be 10 kilo ohm, and let us assume a load resistance of 2 kilo ohm. So these are the two non-idealities of the source and the load. Of course, R1, R2 is going to have a loading effect. So in the previous video, we actually got the expression for H11, H12, and H22. So we know that H11 was given by R1 parallel R2, and H12 was given as equal to R1 by R1 plus R2, and 1 over H22 was given by R1 plus R2. So with this as the circuit connection, so since we are assuming the values of R1, R2 to be 1K and 1000K, so let us try to find out what is the values of H11. So upon finding the values here, so this will become 990 ohms, and this will become 0.001 approximately, and this will become 1001 kilo ohm. So this is a ratio, these two are in resistances. So now with these values, suppose the intention here is, after having a non-ideal load, non-ideal source, non-ideal load, and a non-ideal feedback network, we are asked to find what is the gain of the amplifier after feedback, what is the input resistance after feedback, and then what is the output resistance after feedback. So this is what we are asked to find. That's what we are asked to find. So, so this is, let me say it as simply Ri, let me simply say it as Ri and R naught. So let me just write it, so let me just say it why I just slightly modified it. Let me simply say this as Ri and R naught are the input impedance of the amplifier after feedback. This is output impedance of the amplifier after feedback. So we have a similar type of thing being represented here. So here you can see because of these non-idealities have been pushed onto this amplifier, we have to find a new value of A. So this A is actually A new is actually equal to V naught by Vm. Suppose if I say this is plus, okay, now what I do is let me just, okay, if I actually rewrite this and what is this Vn is, let me just write only the amplifier part of it. If I just carefully write the amplifier part, so this is how it looks. So this is R naught, this is A into Vi, this is RL, this is 1 over H22, this is RS, this is H11, this is RID, this is plus minus Vi, this is what I'm calling as V in plus minus, therefore this is V naught. So this is how the amplifier will look like after pushing this RS here, H11 here, and so on. So we are looking at what is gain of this amplifier with this RS, H11, RL, and H1 over H22. So from this, so what is this A new is actually V naught by V, that is this V naught by this V. So if you want to actually find out the, of course, we have already seen this in the previous case. So let me just reiterate that. So V naught is given by, so A into Vi multiplied by the resistance RL in parallel with 1 over H22 divided by R naught plus RL parallel with 1 over H22. But what is this Vi? But Vi is equal to V in into RID divided by RID plus RS plus H11. So I can write finally the expression of V naught by V in, which is equal to now, which is now equal to A new. Can I write it as equal to the earlier gain RL in parallel with 1 over H22 divided by R naught plus RL in parallel with 1 over H22 multiplied by RID divided by RID plus RS plus H1. So let us try to find out what are the values of this. So RL in parallel with this happens to be almost 1. Okay, let me just write it as this is actually 10 power 4 into 1996. This is the value approximately. This is R naught is actually 1K. It is 1K plus 1996 multiplied by RID is 100K. Again, it is 100K plus RS is actually 10 kilo ohm plus H11 is 990 ohms. So this is 990 ohms. So upon simplifying this, we will get it as 6002, which you can write it as almost 6000 volt per volt. See now, the gain which was open loop gain which was 10 power 4, A was actually equal to 10 power 4, has been reduced to 6000. Of course, 10 power 4 is nothing but 10,000. So 10,000 was the gain without considering the non-idealities. If we consider the non-idealities of the source, load, and the feedback network, the open loop gain itself reduces to 6,000. So with this 6,000, I have to find out what is the input impedance and output impedance and the gain of the amplifier after feedback. So we know that gain of the amplifier after feedback is given by AF is equal to A by 1 plus A beta. Since now it is not simply A, this is A new. Let me write it as now 6000 divided by 1 plus 6000 into 0.001, it will become 6000 by 7. So the value comes out to be, let me just find out what is the value of 1.8. Just looking for the calculator. The value of, I'm finding where is I can see. Okay, this 6000 by 2 will actually become, if I actually have the calculator values, let me just see. Okay, this will become, let me see guys. Let me just do it in my, okay, it is now 6000 divided by 7. You can see now this is 857. 857 volt per volt is the feedback gain after uh, considering the feedback, sorry, the impact of the non-idealities of the source load on the feedback network. And we have to find what is RIF, that is the input impedance of this network. So whenever you're actually finding the input impedance of the network after all these feedback, so if you can actually see, this is actually Ri into 1 plus A beta. What is this Ri? Because we know that the input impedance with feedback is input impedance without feedback multiplied by 1 plus A beta. Because we know what is this. This is actually A nu and then beta values. So actually what is this Ri? Ri is equal to, because this is the input impedance that you are seeing here. The input impedance that is seen here is Rs will come, Rid will come, and H1 will come. So Ri is equal to Rs plus H11 plus Rid. This comes out to be, so we know that this value is, okay, this is Rs is 10K, H11 is 990 ohms, and Rid is 100K. So it is now, we have it as almost, this is, okay, I have the value of this is 110.99 kilo ohm. So that multiplied by 7. So this is Ri. So Ri is equal to now, the input impedance after feedback is 1000, sorry, 110.99K multiplied by 7. If I do that, it is 110.99 into 7. It is actually equal to 776.93 kilo ohms. So this is what is RIF. This is what is RIF. If I actually find out what is this, you can approximately as equal to 777 kilo ohms. So 777 kilo ohms. Let us also find out what is ROF. ROF is actually equal to R naught by 1 plus A beta. This R naught is actually is equal to, see here, this is the value of R naught that you are looking into. Is it not okay? Because when you're finding R naught, you have to make this input as zero. If you make this Vs as zero, this will also become zero. When this becomes zero, this will become short. If you're looking from here, the impedance is, suppose if you're looking from here, or the impedance, it is R naught in parallel with RL in parallel with 1 over H2. So it is now R naught parallel with RL in parallel with 1 over H2, 1 over H2. The value of this comes out to be almost equal to 667 ohms. So then this will become 667 by 7, which happens to be 95.3 ohms, 95.3 ohms, meaning the output impedance of the network, that is ROF that you are looking from here. So now the overall ROF is equal to, 667 ohms. The overall input impedance looking from here is equal to 777 kilo ohms. So this is 777 kilo ohms. Suppose if you are looking at what is the input impedance, you can see for input impedance, you are not supposed to include the value of RS because you are looking from here, because this RS corresponds to Vs, that is the source. If you are looking at what is the input impedance of the network of the amplifier after feedback, it is actually equal to RIF minus RS. So why you are neglecting this RS is because when I actually found out this input impedance after feedback, you can see this is including RS. If you want to get it for only the amplifier which is having the impact of this is, so I have to subtract this RS. So that's why the input impedance of the amplifier excluding RS is, of course, it is RIF minus RS. That is, it is 777 kilo ohm minus RS is 10 kilo ohms. I think RS is 10 kilo ohms. So is it now become 767 kilo ohms? This is the output impedance. Similarly, if you are looking at the output impedance, can you see here the output impedance you have the overall R naught, which is the combination of this and this, the bulk combination of all of them, and of course the feedback factor, and you have a RL. So I need to take out the impact of this RL. I need to take out the impact of RL, meaning then R O, that is the output impedance of the network after feedback, excluding the impact of RL, is actually is equal to, of course, if I write it as 1 over R naught is equal to 1 over ROF minus 1 over RL, 1 over RL. If I do this, so or I can say ROF is equal to RL in parallel with R naught, RL in parallel with R naught. So since we know this, I can find out the value of R naught. So if you actually find out the value of, okay, what is this? If you actually find from this equation, substituting what is ROF is equal to, ROS is equal to 95.3 ohm, and what is RL? RL is equal to, RL is equal to, okay, what I have it as RL is 40. How much is RL? So this is, so this may be 1 over R naught is equal to 1 over RL minus 1 over RL. Suppose if you just do it here, let me use this equation. ROF is equal to RL R naught by RL plus R naught. So what is ROF? What is ROF? ROF is 95.3 is equal to RL is 100K multiplied by R naught by 100K plus R naught. if you actually look for the value of R naught here, the R naught comes out to be close to 100 ohms. R naught comes out to be close to 100 ohms. So what is this R naught? This R naught is the output impedance of the amplifier after feedback, neglecting the impact of the output load. So this is what is R naught. That is excluding this, it is including this. Okay, what I'll do is let me just take this RL here. If I look from here, this is R naught. Or you can write it as, because there is one more R naught, let me write it as R out here. Let me write this as again R out. Okay, forget about this. This is R out. You say this as R out. This is R out, out, out. So what is this R out is? This is the impedance of the amplifier after feedback, output impedance of the amplifier after feedback without considering the impact of RL, without considering the impact of RL. So that comes out to be 100 ohm. How about this Rn? It is the input impedance of the amplifier excluding the Rs. So which was coming out to be 767 kiloohms. 767 kiloohms. And of course, we also know that what is A value? It is coming out to be 857. So what are this is practical values, that is considering the impact of all the non-idealities. How about ideal case? The ideal case we had maybe in the previous video we found it. The, here we actually found out the values. See here, these are the values. There are no ideally, there is no loading effect at all. So it was coming out to be 909, 1210 and 90 point. Sorry, let me just write it. This is 90.9. This was 1210. This was 909. You can see these are the ideal values comparison. So from 909 it reduces to 857. From 1210 kilo ohms, it reduces to 767 kilo ohms. From 90.9, it increases to. This means okay, all the values will deteriorate. So how about the open loop? In open loop, you had a gain of 10 power 4. You had an input impedance of 150k. You have an output resistance of, how much was the output resistance? The output resistance was 1k. Can you see? These are the RID, R0, and A. Here, the ideal case from 1k it reduces to 90. This is the least one. This is the least one. And from 1000, from 150k it goes to this. This is the maximum one. And from this goes to, of course, one of the maximum out of these two. See now, if you consider the non-idealities, this slightly increases, meaning it deteriorates, this reduces, and this reduces compared to this. So the practical consideration and the ideal consideration, you have the practical consideration of loading of all the elements will actually reduce your Rn, slightly reduce your A, it will increase your R naught. So when I say A, it is with feedback. This is with feedback. So this way we can able to understand the impact of all these non-idealities onto the amplifier for an voltage amplifier with voltage series feedback.